Well, hello everybody. Coming to you from my home office on this snow day. Um, Real quick, right off the beginning, um, I'm going to be going through the notes that are on page 13 in the packet and the homework that goes with it. If you just want to write this down real quick, are on the next three pages, pages 14 through 16. But you can go ahead and skip these five problems here 1, 3, 6, 7, and 8. You do not need to do those five problems. I also just drew this graph to help us visualize what we're going to be talking about today. If you want to pause the video and sketch it so it matches, that would probably be helpful. And then when you're ready, you can restart the video. Okay, so in this lesson, we are going to be talking about how to find the absolute maximum or minimum values on a continuous function on a closed interval. So that's exactly what we have right here. We have a continuous function on a closed interval from one point to another. Yesterday, we talked about how to find relative maximums and minimums. And that has to do with when the derivative changes sign, right? If my function, or if the derivative changes from positive to negative, we're going to have a maximum. If it changes from negative to positive, we're going to have a minimum. However, when we are looking for the absolute maximum or minimum, we have to consider a few different things. So if you look at this picture right here, if I asked you to identify the absolute maximum would occur at this point right here, right? That's the absolute maximum. And the minimum point, the absolute minimum, is at this end point here. That's the absolute minimum. So let's talk about where we have possible absolute maximums or minimums. These two are obviously our endpoints. This right here is a critical point, right? The derivative equals 0 right there. This point also is a critical point because the derivative is undefined at this point. We have a critical point here. The derivative is 0. We have that relative minimum. And here we also have a critical point with a relative maximum. And then these 2 points, of course, are our endpoints. So the reason why I show you this picture is because when we're looking at a continuous function on a closed interval like this, the absolute maximum will either be at a critical point or it will be at an end point. Sorry, this packet is not flat. So when you are asked to find the absolute maximum or minimum values, you need to find all the critical points. And remember, when you're looking for the value, you actually have to find the y values. So you're going to find where these x values occur, and then we're going to go ahead and plug it into the function. So this is how you would say it. F of x has an absolute max of whatever the y value is at x equals whatever it is. F of x has an absolute min of whatever the y value is at x equals wherever it is. Now, this is called the candidates test. If this is a free response question on our Unit 5 test or on the AP test, basically you have to show that you have used all possible candidates for the absolute maximum or minimum. So I'm going to change this. You don't have to necessarily refer to the candidates test. You don't have to like say, I know this is the absolute maximum because of the candidates test. But what you have to do is you must show all possible candidates. So essentially, what I will be looking for and what the AP graders will be looking for is, did you know to check all possible candidates? Because sometimes you might get lucky and both the absolute maximum and minimum are a critical point. But if you didn't show that you checked an endpoint, then it's possible that you're not going to get full points for that. So you have to show all possible candidates. So what I'm going to be looking for is that you've checked all the critical points and both of the endpoints. So let's try this example here, and hopefully it'll kind of come together. So it says, find the absolute maximum and minimum values of the function f of x equals x cubed minus 3x squared plus 1 on the interval -1/2 to 4. Okay, so we know this is a continuous function because it is a cubic function and we are on a closed interval. So what do I need to do? I need to, first of all, find all the critical points, and I need to check the endpoints. So I know for sure I'm going to put my candidates over here. I'm going to have to check f of -1/2, and I'm going to have to check f of 4. Okay, so I know for sure I'm going to have to check those. But let's see if we have any other candidates in this interval. So to find critical points, remember a critical point is where our derivative is either equal to 0 or is undefined. So my derivative, we're going to get 3x squared minus 6x. All right, this is never going to be undefined. It's simply a quadratic. So I'm just going to find where it equals 0. To solve this, I can factor out a 3x. And from this, we can see that we're going to have critical points at x equals 0 and x equals 2. So this now has given me my two other candidates. So my absolute maximum and my absolute minimum are going to occur at one of these 4 points. It's either going to happen at the critical point or at the end points. So what I have to do now is actually go through and figure out what I get when I plug those in for x. So I'm going to do 0 real quick because that's easy. If x is 0, we get 1. All right, f of 2, let's see, that's 8. 2 squared is 4 times 3 is 12. So that's -3. F of 4. 4 cubed is 64. 4 squared is 16 times 3 is 48. So 64 minus 48 is 16, plus 1 is 17. Okay, last one. Save the toughest one for last, right? Okay, -1/2. -1/2 cubed is -1/8. -1/2 squared is 1/4 times 3 gives me -3/4 plus 1. Okay, so let's real quick do some common denominator. -1/8 minus 6/8 plus 8/8. So what does that give me altogether? That gives me 1/8. Okay, so I have done the first two steps. I found all the values of f at my critical points and at the endpoints. And now essentially I'm just going to compare and say, okay, which one's the biggest and which one's the smallest. And when you look at it, it's pretty obvious. This is going to be my absolute maximum, and this is going to be my absolute minimum. So then I state my conclusion, and I will use this exact wording. I'm going to say f of x has an absolute max of 17. We use the y value at x equals 4, and an absolute minimum of -3 at x equals 2. And that would be the whole problem. So that's basically it. We find the critical points and plug those values and the endpoints into the function, and you're figuring out what one's the biggest, what one's the smallest. Okay. Also, this is why it's important to check the endpoints, because if I had only checked the critical points, we would have said that the maximum occurs at 0. Now, there will be a relative maximum at 0, right? We can imagine a cubic function. A cubic function is going to look like this. Okay, so what do we have happening? We have a relative maximum happening at 0, and we have a relative minimum happening at 2, and then it increases from there. However, I'm only looking at the function, this chunk of the function. So on that interval, this is, in fact, the absolute minimum. And then the maximum is going to be all the way over here. All right, let's try one more example. Use your calculator to help you find the absolute maximum and minimum values of the function x minus 2 sine x on the interval 0 to 2 pi. Okay, so again, absolute means I need to check all candidates. So I know I'm going to have to check f of 0 and f of 2 pi. And let's just do that right now. So f of 0, we would have 0 minus 2 sine 0. Sine 0 is 0, so we got 0. 2 pi, same thing. Sine of 2 pi is 0. So f of 2 pi is 2 pi. All right, now we're going to take the derivative so we can find the critical points. F prime of x is 1 minus 2 cosine x. So I want to know when this equals 0. That's never going to be undefined. So if I rearrange that, that means I have 1 equals 2 cosine x, or 1/2 equals cosine x. So on my interval 0 to 2 pi, I have to think about where does cosine equal 1/2. And again, I know I've mentioned it before, but you need to make sure that you have a good knowledge of the unit circle. Cosine equals 1/2 right here at pi over 3. It also equals 1/2 down here at 5 pi over 3. So my other critical values are going to be here. So f of pi over 3 and f of 5 pi over 3. Okay, so f of pi over 3 means that I'm going to have pi over 3 minus 2 times sine of pi over 3 is square root of 3 over 2. Now, I don't quite know what that value is. I don't know about you. So I'm just going to punch that into my calculator here. So pi divided by 3 minus, well, those are going to cancel out, right? So just minus square root of 3. And what do we have? Negative 0.685. So negative 0.685. And 2 pi is 6.28. So we have that for reference. Okay, 5 pi over 3. So I'm going to have 5 pi over 3 minus 2 times, now sine of 5 pi over 3 is negative square root of 3 over 2. So once again, I'm going to cancel those out, and that's going to be 5 pi over 3 plus square root of 3, which gives me 6.968. 6.968. Now, once I have this, I simply am going to compare, and you can see that our critical points were both the minimum and maximum. However, this is an example where, if you hadn't thought to check the endpoints, you would have gotten the right answer. However, you would not earn full points because you did not show your understanding that you needed to consider the endpoints as possible candidates. So in order to receive full points, you have to show that you looked at the function values of both the critical points and the endpoints. So to write my conclusion, I would say f has a maximum, I should say an absolute maximum of 6.968, remember 3 decimal places, or you could even write the actual value like this. But either one is fine. F has an maximum of 6.968 at x equals 5 pi over 3, and an absolute minimum of negative 0.685 at x equals pi over 3. All right, so that is the candidates test. Just a reminder, your homework is on the next few pages here, and you can skip those 5 problems. So here's page 14. So again, you can skip 1, 3, 6. So you're only doing 3 problems on this page. And then you can skip these graph problems. I'd like to go through these ones together when you come back to school on Thursday. And then we have a couple more problems on page 15 and then 16 as well. All right, that is it. We will see you on Thursday.